Good day. Types of metrics. Types of metrics. Today we'll be looking at different types of metrics. So let's start with what we call square matrix. Square matrix. Square matrix. Now, square matrix. This is a matrix in which the number of rows is equal to the number of columns. This is a type of matrix in which the number of rows is equal to the number of columns. For example, matrix M is equals to A11, A12, A21, A22. So this is a 2 by 2 matrix. And the number of rows is equal to the number of columns. So you can say that matrix, or let's consider something like this. Matrix A is equals to, let's say, A11, A12, A13, A21, A22, A23. So you can't call this a square matrix. This is not a square matrix. This is not a square matrix because this matrix does not have the same dimension. This is what we call 3 is a 3 by 2 matrix. This is 3 by 2 matrix. So you can't call it a square matrix because the number of rows and the number of columns are not the same. But you can call this matrix A. You can call something like, okay, matrix A, A11, A12, A13, A21, A22, A23, A31, A32, and A33. So you can call this a square matrix because this is a 3 by 3 matrix. The order is 3 by 3 because it has equal row and equal column. So what I'm saying in summary, a square matrix is the type of matrix that has equal rows and equal column. Example, we have 2 by 2, we have 3 by 3, and so on and so forth. Now let's look at the next one. Look at the next one. Row matrix. Row matrix. Now, row matrix, this is a matrix that has exactly one row. This is a matrix that has exactly one row. Let's say, for example, matrix A equals to A11, A12, A13. So this is a 3 by 1 matrix. This matrix is called a row matrix because it's made of exactly one row. Exactly one row. Now let's look at another one called column matrix. column matrix. Column matrix For column matrix, you know what to do. If the row matrix is a matrix that has just one row, so what do you think the column matrix should be? That means the matrix with what? Just one column. Let's say, for example, our matrix A being equals to our A11, our A21, our A31. So this is what we call a column matrix. A column matrix. Now the next one, that's what we call null or zero matrix. The next one, null or zero matrix. Null, you don't call it a null, or you call it zero matrix. Now, null or zero matrix. Now, this is the type of matrix that has all its elements as zero. That means all the elements of this matrix is zero. Let's say, for example, matrix B equals to 0, 0, 0, 0, 0, 0. So this is a matrix of order that is 3 by 2. So this is what we call zero matrix. What is zero matrix? Because it has zeros as its elements. It has zeros as its elements. So the next one, let's look at what we call diagonal matrix. Diagonal matrix. Now, this type of matrix has number in its main diagonal, then zero elsewhere. Now look at diagonal matrix. Diagonal matrix. So this type of matrix has numbers in its main diagonal and zero elsewhere. Now let's assume this is the matrix A being equals to our A11, our A12, our A13, our A21, our A22, our A23, our A31, A32, A33. So where's the main diagonal? The main diagonal is here. That is A11, A22, A33. So is the main diagonal. And so when we talk about diagonal matrix, now this part A11, A21, A33 has numbers, while the remaining part here being A21, A31, A32, and A12, A13, and A23 has zero. So for let's say this matrix is a matrix B, we have to translate this. So we talk about the main diagonal, talk about A11, A21, A33. That's the main diagonal of a matrix. That's the main diagonal. So when we talk about diagonal matrix, that means this part. So our part of let's say A11 is, let's say we have 1 here. Our A12 we have 0. Our A13 we have 0. Our A21 we have 0. Our A22 can have any number, let's say 3. Our A23, let's say we have 0. Our A31 we have 0. Our A32 we have 0. And our A33, let's say we have 5. So the main diagonal, so this is the type of matrix that have what? That have numbers in its main diagonal and 0 elsewhere. So the main diagonal now is A11, A22, and A33 is the main diagonal of a matrix. So you can now consider this as what? A diagonal matrix. And this take us into what we call triangular matrix. Triangular matrix. Now triangular matrix now is of two types. There is a triangular matrix. Triangular matrix. Now for triangular matrix, it's divided into two. That is, we have what we call the upper triangular, and the lower triangular matrix. Now, for the upper triangular matrix, and this part of matrix, let's say matrix A, as example of the upper triangular matrix. Say matrix A equals to, that is 1, 2, 3. Okay, sorry, this is not 3, 0. Sorry, this is 0. Okay, and then we have here 0. It's not 2, it's 0. Here 0. And let's say we have here 1, 3, 2, 4, 6. Now this is upper triangular. Why is it upper triangular? Because below here we have 3 zeros, and that means this below this matrix we have 3 zeros, and that means our A21, our A31, and our A32 is 0. Then the main diagonal and the other part of the matrix is made of numbers. So now for the lower triangular matrix, we have the same thing. That means for the lower triangular matrix, now our the upper part of this matrix is 0, while the other part is our numbers. Now let's demonstrate it so you can understand what I'm talking about. Let's demonstrate this so you understand what I'm talking about. That what I'm saying here is, let's say matrix B. Let's say matrix B is equals to, that is 1, 0, 0, 2, 4, 0, 1, 1, 1, for example. Now, yes, they all call the lower triangular matrix, because we check very well here. Why A12, our A13, and our A23 are all 0. Here is 0, while the remaining part of it is in our numbers. And there's another one called unity matrix. That's unit matrix or identity matrix. Unit matrix, or you call it identity matrix. Yes, identity matrix. Let's start with this matrix is denoted by I. So it's given as, this is a type of matrix that has, now it's a square matrix. Identity matrix is a square matrix. So this square matrix has elements in the main diagonal and 0 elsewhere. So it has 1 as element in its main diagonal and 0 elsewhere. So let's say, for example, we have this as 1, 0, 0, 1. So this, the main diagonal here is 1, 1, then 0 elsewhere. This is a 2 by 2 square matrix. Then for 3 by 3, we have 1, 0, 0, 0, 1, 0, 0, 0, 1. Now this is a 3 by 3 unity matrix. So this type of matrix has one as in its main diagonal, like 1 in its main diagonal and 0 elsewhere. So this is what we call a unit or identity matrix. There's another one called singular matrix. Singular matrix. Singular matrix. For singular matrix, now this type of matrix has no inverse. In short, that means a determinant is 0. So talking of singular matrix, a singular matrix type of matrix whose determinant is 0 or that does not have any inverse. So any matrix that does not have an inverse or whose determinant is 0 is called a singular matrix. So that means if it has something, any other number, maybe this matrix have an inverse and it has an inverse and it has other numbers as determinant, let's say from 1 and above, we call it a non-singular matrix. But as long as a matrix has no inverse or has a determinant as 0, such matrix is called a singular matrix. Let's say, for example, now let's say a matrix like this, let's matrix A now is equals to, let's say 3, for example, minus 2, minus 3, 2. So this matrix, this is an example of a singular matrix because its determinant is 0. So let's solve it and see what I'm talking about. Now, the determinant of this matrix here is 0. And let's check. Our 3 times our 2 here, we have 6 minus 2 times minus 3. We have plus 6 equals to 6 minus 6 is 0. So this is an example of a singular matrix because its determinant is 0. It has no inverse. There's another one called equality matrix. Equality matrix. Equality matrix. Now, equality matrix. Okay, so let's look at equality matrix. So the two matrices, let's say A and B, are equal if and only if they have the same order, and each element of one is equals to the corresponding elements of the other. And let me illustrate it there for you. Let's say, for example, you have matrix A. So matrix A is equals to 4, 3, 8, minus 1, 6, minus 2. Then matrix B equals to 4, 3, 8, minus 1, 6, minus 2. Now, matrix A is equals to matrix B because they have the same order, this is a 3 by 2 matrix. Here is also a 3 by 2 matrix. So it's equals to B because why A and A is equals to matrix B is that one, they have the same order, and two, all the elements in A is the same, is equals to the elements in B. So that they are corresponding. Let's say for a matrix A, our A11 is 4. Matrix B, our B11 is 4. Matrix A, our A12 is 3. Our B12 here is also 3. So as and so on and so forth. So they have the same order, the same elements, the same corresponding elements. So that's what makes them equal. Now let's solve this particular example. Let's say example 1. Example 1. Now given matrix A equals to 3 minus 5 y 2 x 0, then which is B equals to m q 7 2 minus 1 n. Now the question is find x, y, m, n, q if A is equals to B. So our solution so our x will be equals to, what's our x? Our x here will be equals to minus 1. Our y will be equals to, what's our y? 7. Our m equals to 3. Our q is equals to minus 5. And our n is equals to 0. So that is it. Very simple, nothing to solve there. So that is it. Now there's another type of matrix called conformable matrix. Conformable matrix. Conformable matrix. Now this type of these two matrices A and B are said to be conformable matrix when the number of column of A is equal to the number of rows of B, or vice versa. So that means matrix A is said to be conformable with matrix B if and only if matrix A has the number of rows of matrix A is equal to the number of column of matrix B. So let's consider this matrix A, for example. Let's say matrix A is equals to, for example, let's say A11, A12, A13, A21, A22, A23. Then our matrix B is equals to our A11, our A12, our A21, our A22, our A31, our A32. Now, A is conformable to B because now for matrix A we have this is a 3 by 2 matrix, and here is a 2 by 3 matrix. So why is it conformable? It's conformable because now for matrix A have three rows. It has three rows. Then our matrix B has three column. So it's conformable because the number of rows of matrix A is equal to the number of column of matrix B. That's the reason why it is that this matrix are conformable matrix. Now let's look at another one called symmetric matrix. Symmetric. Symmetric matrix. Now for symmetric matrix, let's consider this matrix here. Let's consider matrix A equals to 3 minus 2 minus 2 1. Now before we do that, what is the transpose of the matrix? Now we'll look at that in our next class, but we can as well do that as an assignment. Now, why is it talking of school symmetric? Symmetric matrix. So symmetric matrix, this type of matrix whose transpose is equals to the matrix. That means the transpose of matrix, when the transpose of matrix equals to the matrix, such matrix is called symmetric matrix. For example, now this is our matrix A with the order. This is a 2 by 2 matrix. And the transpose of this matrix now, A transpose is equals to, now for A transpose, that means if you are to transpose the matrix, that means the first row becomes the first column, which will now be 3 minus 2, and the second row becomes the second column, that is minus 2 1. So you check the same thing. Choose the same thing. Then you observe, you discover that matrix A is equals to its transpose, A transpose. So this is what we call this a symmetric matrix, because this particular matrix is equals to its transpose. That's what makes it a symmetric matrix. And so another one called skills. For this level, stop at skill symmetric matrix. Skill symmetric matrix. The last one, let's look at skill for the level. We have other types, idempotent and other type of matrix, orthogonal and others. But we'll stop at skill symmetric. We don't call it skill symmetric, we call it anti-symmetric matrix. So skill symmetric. Let's consider this matrix here. Let's consider matrix A equals to 0 minus 2 3 2 0 minus 5 minus 3 5 0. Then matrix B, sorry, A transpose. To transpose this matrix, take note the first row become the first column. So we have 0 minus 2 3. Second row, second column, we have 2 0 minus 5. We have minus 3 5 0. Now A transpose is equals to minus A. What does that mean? It means that the matrix A is said to be skew symmetric if its transpose is equals to its negative. Now, what do they mean by if its transpose is equal to its negative? Let me illustrate to you now. Now, talking of anti-symmetric or skew symmetric matrix. Now, this you call it a skew symmetric because when the transpose of the matrix is equals to the negative of that matrix, then that means it's skew symmetric. For example, now this is our matrix. so these are transpose, right? So that's 0, 2, minus 3, minus 2, 0, 5, 3, minus 5, 0, right? Now our main matrix is 0, minus 2, 3, 2, 0, minus 5, minus 3, 5, 0. Now what they mean there is the minus of this transpose. If it's equals to this particular matrix, that means it's skew symmetric. So that means let's multiply minus through this matrix here, through this particular, let's multiply everything here with minus sign. Let's say minus 1. Let's multiply everything here with minus sign. To discover that we'll have minus times 0 is still 0. Minus times 2, that we have minus 2. Minus times minus 3, we have positive 3. Minus times minus 2, we have 2. Minus times 0, we have 0. Minus times 5, we have minus 5. Minus times 3, we have minus 3. Minus times 5, we have plus 5. We have 0. Now, this is a skew symmetry because the transpose is equals to the negative of that matrix. So, this is what we call skew symmetric or anti-symmetric matrix. So, in our next class, we'll look at addition and subtraction of matrices. So, that is addition and subtraction of matrix. So, do well to subscribe for more.